So this topic is called probability of 5-card hands. The question says, here's a table showing all 52 cards in a standard deck. So I just kind of got it organized for you to help you count and keep track of how many of each suit and what kind of cards you have. A 5-card hand is dealt at random from a standard deck. So you shuffle the cards up and you deal out 5 cards. So a 5-card hand is any set of 5 cards, in other words, chosen without replacement, and that means that the order doesn't matter, right? So we're dealing with combinations. What is the probability that the hand contains exactly 1 3? So to answer this question, you need to think about how many hands, how many 5-card hands with exactly 1 3, and then how many 5-card hands. So the total number of 5-card hands. So to find the probability, sorry about my bad handwriting there, find the probability that you get dealt a hand that has exactly 1 3 in it. Means how many, you figure out how many 5-card hands exist with exactly 1 3, and just how many 5-card hands exist at all. And when you divide those two, that gives you that probability. So what we're dealing with here, the simple one first is just how many 5-card hands are there. So that means there's 52 cards, and we're looking for the combinations of choosing 5 of them out of 52. So if you do 52C5 and crunch that out with your calculator, that is 2 million, and a lot of poker players have this number memorized, 598,960. So that's how many 5-card hands there are in that can be dealt from a deck of cards, a standard deck of cards. And then we got to think about this numerator. So that is my denominator. And then we got to think about this numerator and say, okay, now what? So first of all, how many 3s are there? Well, if I look at this right here, there are 4 3s in a standard deck. So if I'm going to get exactly 1 of those 4 3s, then I have to think about how many different ways can I choose 1 3 from those 4 3s. So that's 4C1. And then I also have to think about how many ways can I fill it. So that gives me 1 of my 3s. So think of it this way. Here's my 5-card hand. There's 1 3. And then I need 4 more cards. So how do I fill out the rest of my deck? So that means if I've already considered getting 1 of those 3s from the 4, then I have to get 1 more card from the 48 non-3s. So 48, choose, that's an ugly C, choose how many more cards am I getting? Well, I need 4 more cards. So I'm choosing 4 from the 48 remaining non-3s. So then I want to multiply those two things together. So I have 1 3 chosen from the 4 3s, and then 4 more cards chosen from the non-3s, because if I'm going to get exactly 1 3, I can't include any of the 3s where I'm choosing the remaining cards. So they have to come from the 48 non-3s, and where 48 comes from, in case you're wondering, is 52 minus 4. So there are 48 other cards that aren't 3s that I can choose from. So again, fundamental accounting principle, how can I do both of those things, get 1 3 and then 4 more other cards? I multiply those two things together, and so that is, and I'm kind of making a mess out of this, but I'll just write it above it. So 4C1, that turns out to just be 4, And 48 C4, that turns out to be 194,580. And if you multiply those two together, you get 778,320. So that's my numerator, and we already had the denominator was that 2 million number. So to make that up as my fraction, then the number of ways I can get a 5-card hand with exactly 1 3 divided by the number of 5-card hands, I get this fraction, 778,320 divided by this 2,598,960. And if you divide that on your calculator, you get 0.299. And so it tells me to round to the nearest hundredth. That's 2 decimal places. So final answer is 0.30. So the probability that my hand contains exactly 1 3 is 0.30. I'll show you really quickly the ALEKS solution here. It's pretty much exactly the same. So number of 5-card hands is exactly 1 3. Number of 5-card hands total. There's the number of 5-card hands total. There's the number of 5-card hands with exactly 1 3. So again, that's that 4C1 times 48C4. And you can read any of that. That says more or less exactly the same thing I said. And final answer, same thing, we got 0.30.